discuss the principle and action of a Bainbridge mass spectrometer to determine the isotopic masses. Bainbridge mass spectrometer is an instrument used for the accurate determination of atomic masses. A schematic diagram of this spectrometer is shown here. Atoms with one or more electrons removed have a net positive charge and they become positive ions. A beam of positive ions produced in a discharge tube is collimated into a fine beam by two narrow slits S1 and S2. This fine beam enters into a velocity selector. The velocity selector allows the ions of a particular velocity to come out of it, but the combined action of an electric and a magnetic field, the velocity selector consists of two plane parallel plates P1 and P2, which produces a uniform electric field E, and an electromagnet to produce uniform magnetic field B. These two fields are at right angles to each other and to the direction of the beam. The electric field and magnetic field are so adjusted that the deflection produced by one field is nullified by the other, so that the ions do not suffer any deflection within the velocity selector. Let E and B be the electric field intensity and magnetic induction respectively, and Q be the charge of the positive ion. The force exerted by the electric field is equal to QE, and the force exerted by the magnetic field is equal to BQV, where V is the velocity of the positive ion, QE is equal to BQV, V is equal to E by B. Only those ions having this velocity V pass out of the velocity selector and then through the slit S3 to enter the evacuated chamber D. These positive ions having the same velocity are subjected to another strong uniform magnetic field of induction B' at right angles to the plane of the paper acting inwards. These ions are deflected along the circular path of radius r and strikes the photographic plate. The force due to the magnetic field B'QV provides the centripetal force. B'QV is equal to mv square by r. M is equal to B'QR by V. Substituting, we get M is equal to B'QR by E. Ions with different masses trace semicircular paths of different radii and produce dark lines on the plate. The distance between the opening of the chamber and the position of the dark line gives the diameter 2r, from which radius r can be calculated, since Q, B, B', E and R are known the mass of the positive ions, and hence isotopic masses can be calculated.
Please subscribe our channel for more videos and educational contents.